In this presentation, I'm going to look at a confidence interval question for proportions or percentages. And in this particular instance, what I'm going to do is I'm going to look at a 99% confidence interval, which is different from the usual 95% confidence intervals, usual in undergraduate statistics. Essentially, this is the key variation here. So calculate a 99% confidence interval for the percentages of claims for household accidental damage which are fully settled within 6 months of being submitted, given that in a random sample of 100 submitted claims of this type, exactly 83 were fully settled within 6 months of being submitted. Now, it tells you explicitly that it's a percentage or a proportion, okay? But if not, you can use those two figures there, 100 and 83, as in 83 out of 100, to deduce what type of question we're being asked, that it is about proportions. Okay, so the general structure of a confidence interval, this is one sort of approach, a sort of format I would use on almost every single case with regard to confidence intervals. Well, most of the introductory type stuff anyway. Point estimate plus or minus quantile times standard error. Okay, so in this particular video, in this particular presentation, the point estimate is the sample proportion. This is what we have to deduce. Is it a sample proportion? Is it a sample mean? Or is it something else? So p hat, which is our estimate, our sample proportion, our estimate, is equal to 83 out of 100, which is 0.83, 83%. Now, the confidence interval here is a 95% confidence interval, or 99% even, watch out for that. And essentially, we are dealing with a large sample. We nearly always are dealing with large samples, particularly with proportions, but it's always good to sort of state categorically that we consider this a large sample and therefore that the sampling distribution is approximated by the normal distribution. Okay, just for the A1 answer, just state that. So these are the quantiles. Now, these are actually found either using statistical tables or a programming language called R. So either tables or R or something like that. Essentially, what we have to do here is calculate these. So, or come up with the relevant values. So I just remarked that there is actually a typo on that, and it actually is the 0995, the 99.5 quantile that we're using here. Now, if you're not quite sure where that comes from, I won't deal with that in this video, but essentially 99.5% quantile is what we need to calculate the quantile it's the quantile we would use for a 99% confidence interval. Okay, so it's 2.576. Okay, now there's a little typo there as well. Okay, but anyway, that's the one we're using. 2.576. The next part is the standard error, and the standard error is usually given in the back of the exam paper or in tables or something like that, but quite often you might have it learned off after enough practice that you could do them automatically without having to look them up. So it's the square root of p hat times 1 minus p hat over the sample size n. And here p hat, the sample estimate, the sample proportion is 0.83. The complement of that is 0.17. So we multiply them out, divide by the 100, and we get the square root of that. Okay, so we get the square root of 0.001411, and I think it's just good to go to 6 decimal places at that particular instance, but then overall work to 4 decimal places. That's just my own personal preference. 0.0376. Okay, so our 99% confidence interval, oh, there's another typo. 99% confidence interval is 0.83 plus or minus 2.576 times 0.0376, and again, allowing for a little bit of rounding error, 0.83 plus or minus 0.0968. Working that out, we get these two values here. The upper and lower bound of our confidence interval, 0.7332 is the lower bound, and the upper bound is 0.9268. Okay, so you can express this as a percentage there, and one decimal place there if you want. This actually depends on which discipline you're studying statistics for, really. Okay, but just as a default, let's go to 4 decimal places until you know what you need to do for your own particular subject. Okay, we'll leave it there. That is a second confidence intervals for proportions question.